the cheapest one available as long as I find my dose. So if you'd be interested, I can show you this a bit later on. But this afternoon, we will be focusing on a different topic, even though it is the second topic in the series that I have called Forever Young. And we will deal with changes in a different body system related to aging. Okay, so I will start again with the same quote as we saw last night. Aging results in profound changes that affect all systems, organs, and tissues. And here I have a summary of what is happening in gastrointestinal system as a result of aging. Okay, so number one, notice as we age, we secrete smaller amounts of hydrochloric acid. Hydrochloric acid is secreted normally, naturally speaking, in the stomach or by the stomach. And the hydrochloric acid that we do secrete is actually weaker. If you recall back when you took a chemistry class, we measure pH in the scale of 0 to 14. Remember, the higher the number, the weaker or more alkaline the solution, remember? So when we are in our 20s, maybe 30 years old, the pH of the stomach's hydrochloric acid is about 1.5, maybe even slightly lower for some, which means that it is very strong, very acidic. But as we age, when we get to be 50 and perhaps 60 and older, that pH is actually higher. It may be 2, maybe 2.5, and that 0.5 or 1 unit makes a big difference. And then lastly, we also secrete smaller amounts, or maybe even know of a very specific protein type that we called the intrinsic factor. Now I know this may be new. You may not have heard of the intrinsic factor. I hope you will remember this particular term from now on, because this is actually a very important compound that impacts the absorption of a very important nutrient that we call vitamin B12. Okay? Now notice how these changes impact absorption of vitamin B12. First, we ingest vitamin B12 with foods. Okay? As we ingest vitamin B12 with foods, vitamin B12 is actually bound to protein. And in order for us to absorb that B12, we actually have to split that B12 from that protein, which means we have to digest that bond between protein and vitamin B12. Now, this is done through the action of the hydrochloric acid and pepsin, which as we age, remember, we mentioned that we secrete less of, or we secrete smaller, weaker of hydrochloric acid. So that splitting of B12 from the protein may be impaired, okay? And unless we actually release the B12 from the protein, we will not be able to absorb vitamin B12. But this is not the end. Notice that as vitamin B12 is released from the protein, it is then picked up by this compound we name the intrinsic factor. And here we have what scientists call B12 intrinsic factor complexes. And only when B12 is bound to this compound called the intrinsic factor, we can actually absorb vitamin B12. And again, as we age, we secrete less of the intrinsic factor or no intrinsic factor. If we are at the point where we secrete negligible amounts or no intrinsic factor, regardless of how much dietary vitamin B12 we ingested, we may go to Burger King or McDonald's and order the vitamin B12. As a result, gradually we may have lower and lower and lower serum vitamin B12, and then this will translate, notice that it will translate, the serum vitamin B12 will translate into inadequate concentrations of vitamin B12 in the cells, in the brain, in milk, for example, breast milk, for example, when we are talking about breastfeeding women. By the way, notice that not only I included here malabsorption, which would be potentially the case with older adults and elderly, but I also included inadequate intake. And in this category, or this is a core or the reason why many vegetarians and vegans also develop vitamin B12 deficiency. Vitamin B12 naturally is only found in meats and foods of animal origin, meaning vitamin B12 is found in foods that nutritionists and dietitians tell people to eat less of. When you actually consider burgers or sausages and other items that we commonly call processed meats, we are advised to avoid eating those altogether. When we consider red meats, beef, pork, goat meat, rather, horse meat, and yes, people do eat horses. If you don't believe me, go to Italy for vacation, for example. You know, these are examples of red meats, and they contain vitamin B12, but again, we tell people to either avoid eating them altogether, or, you know, let them in small amounts, okay? And so the inadequate intake, just like inadequate absorption, which is what this means, may mean inadequate amount in the serum, and that will also translate into, again, inadequate concentration in cells, brain, and milk. And we actually have many case studies or case descriptions, publications of infants or toddlers that have been breastfed by a mother who was deficient in vitamin B12, and that infant and or toddler developed very profound symptoms of vitamin B12 deficiency. And oftentimes, in cases of infants and young children, even though we can very successfully and very rapidly treat hematological symptoms of vitamin B12 deficiency, they also develop neurological symptoms, which are very hard to treat, and they oftentimes have years of spent the entire career studying vitamin B12. Dr. Allen from California published in the best nutritional journal in the world, the American Journal of Clinical Nutrition. And here's what it states. Vitamin B12 deficiency and depletion, notice what it says, are what? Are common, are not rare, are common in wealthier countries, particularly among the elderly, and are most prevalent in poorer populations around the world. This prevalence was underestimated in the past for several reasons, including the erroneous belief that deficiency is unlikely except in strict vegetarians or patients with pernicious anemia, and that it usually takes 20 years for stores of the vitamin to become depleted. Now, again, the strict vegetarians often do develop vitamin B12 deficiency, but they are not the only ones. The view was that, oh, some vegans here and there might develop vitamin B12 deficiency. It doesn't sound like some people here and there develop, right? It sounds like this is a fairly common occurrence, right? In fact, the subtitle of my book, Vitamin B12, is Combating the Epidemic of Deficiency. We know that vitamin B12 deficiency is a worldwide problem, okay? Let's look further. What happens when we have low serum vitamin B12? So here on this axis, notice I have a value for serum vitamin B12. Notice that as serum vitamin B12 decreasing, a compound that we call homocysteine increases, okay? And again, you may or may not have heard of homocysteine. It is another compound that it might be useful to actually remember. Homocysteine is like cholesterol. You probably have heard of cholesterol, right? Okay? Did you know that cholesterol is essential for our health? It's absolutely essential. And this is why all of our cells make cholesterol, actually. We don't necessarily have to ingest foods that contain cholesterol, because all of our cells make cholesterol. But what happens when we have elevated cholesterol level? Elevated cholesterol is a risk factor for different cardiovascular complications. Not only though, elevated cholesterol is a risk factor for things like dementia, Alzheimer's, for example. Okay? And the same is with this compound homocysteine. And I will introduce you to some health complications related to higher than normal homocysteine level. Homocysteine is an essential compound, just like cholesterol. But elevated homocysteine concentration is worse than elevated cholesterol because it contributes to a variety of detrimental health problems. Let's look at the data from the Adventist Health Study 2 on homocysteine status among members of the Seventh-day Adventist Church who are included in the Adventist Health Study 2. I am one of them, okay? I know some of you are members of the Adventist Church, so this may be relevant to you. Notice that here we have data based on diet group. So among the vegans, 45% had elevated homocysteine level, okay? Now, keep in mind, I want to go back for a second here, that low B12, or rather elevated homocysteine means what? It translates to what? Vitamin B12 deficiency, or at least insufficiency, okay? So let's keep this one in mind as we look at this particular data, okay? Here we have data for lacto-ovo vegetarians, about 30%, and you see the other diet groups, okay? So we have very high prevalence of elevated homocysteine, which again translates to inadequate vitamin B12. But there's also an interesting nuance in this particular data set. I want you to notice that the definition of what is higher than normal homocysteine level in this particular study was 15 or above, okay? 15 or above. Now, keeping this in mind, let's read this quote here. Notice these scientists say, "We have shown that risk for coronary artery disease is represented by a continuum of total homocysteine concentration with substantial risk occurring between how much? Between 10 and 15. May I suggest to you that the definition of what constitutes elevated homocysteine should not have been 15, but should have been 10. Now, if this was the case, I also would like to suggest to you that we will see higher, possibly much higher prevalence of elevated homocysteine in the group of Seventh-day Adventist members included in this particular analysis, okay? We already learned that, again, the level of B12 impacts homocysteine level. Notice here in this particular data set, in order to keep homocysteine at 10 or below, our serum vitamin B12 should have been what? Or should be about, or roughly 330 maybe, okay? Or higher, okay? Yet, when we look at, for example, the level among lacto and lacto-ovo vegetarians, the average serum vitamin B12 was 209 and homocysteine almost 14. When we look at what it was among vegans it was 172 and homocysteine about or close to 16.5. So, substantially elevated. Now, did you notice that the vegans had almost half the concentration that it should have been to keep homocysteine at 10 or below? And again, I'm not bashing vegans, don't misunderstand me. I told you last night that I am one, okay? But I believe that when we adopt certain lifestyle and certain diet, we should know what we are doing, and we should be aware that we are at risk of a deficiency of specific nutrient, in this case vitamin B12, and we can do a very simple thing, a very easy thing to prevent this from occurring, and I will get to that toward the end of my presentation. Let's look at health outcomes associated with inadequate vitamin B12 status and or elevated homocysteine level. One we already learned. Notice this quote: each increase of 5 micromoles per liter in homocysteine level increases the risk of coronary heart disease events by approximately 20%, independently of traditional coronary heart disease risk factors. I need to elaborate. What are the traditional coronary heart disease risk factors? Things like smoking, things like elevated cholesterol level, hypertension, elevated blood glucose level, inactivity, poor diet, abdominal obesity, okay? Stress. All of these are risk factors, traditional risk factors for developing coronary heart disease. Now, if I am a vegetarian, say, or if I am a vegan, likely the profile of all of these are improved in comparison to non-vegetarians. That's what studies are showing us very clearly. Vegetarians have lower blood pressure. Vegetarians have lower cholesterol level, better blood glucose control. Fewer of them are overweight or obese, and so on and so on. They have higher healthy eating index, for example. Okay? All of these traditional risk factors are better in vegetarians and especially in vegans than in non-vegetarians. Does that mean that a vegetarian or a vegan is not at risk of developing some type of cardiovascular complications like coronary heart disease? I'm going to share with you an experience that I had. It was March 2013. I was invited to go to a church in Charlotte, North Carolina. It was a Seventh-day Adventist church. I had 2 lectures there, and in the intermission between the 2 lectures, this couple came to me. I would say they may have been about 75 years old. And then this gentleman shared with me, he has never, ever once eaten meat in his life. He never had meat in his mouth at all. And then he told me 4 months ago he had quadruple bypass surgery. And then he asked me, why would I have a need for a quadruple or bypass surgery? I remember, this was, like I mentioned, March 2013. The last weekend of September, the same year, 2013, I was back in the same church. And again, I had 2 lectures. And in the intermission between the 2 lectures, this gentleman came to me, church member, and he, I would say, was about maybe a little over 60 years old. And this is what he told me. He said, I had been vegetarian for over 30 years. And then the next thing he said was, 3 months ago I had stroke. And then he said, why would I develop stroke? And believe it or not, I'm not making up, I'm not adding anything to it. When I returned home on Sunday, that week, the first week after that weekend, I started working on a publication, Why Do Vegetarians Develop Heart Disease? Okay? And he is the main reason. It's not the only reason, but he's the main reasons. I just share with you, if you are vegetarian or vegan, you have very few sources of vitamin B12, and therefore you have inadequate intake, likely. Your vitamin B12 goes down, homocysteine goes up, and higher than normal homocysteine level is a risk factor that we call non-traditional risk factor for developing cardiovascular complications, including coronary heart disease. Let's go on. Let's move at explain how is it possible that this homocysteine is actually a risk factor for heart disease. So here I have another a quote for you. You may have noticed already, I would like the authors of the publications to speak more so than you just believe me here. Okay, let's notice here. The epidemiological data linking homocysteine with atherosclerosis is strong. Experimentally, homocysteine stimulates a range of potentially pro-atherosclerotic changes, including inflammation. Remember we mentioned last night that cardiovascular disease, atherosclerosis, is an inflammatory disease, that thrombosis, and causes apoptosis of endothelial cells. Now I know this may be like, what? Okay, so let me explain this, okay? I'm gonna focus on the word apoptosis and the endothelial cells. So when we look at the inner surface of the arteries, they are lined with what we call endothelial cells, okay? And apoptosis, the medical term apoptosis means dying or death of, okay? So the quote was referring to the death of the cells that are found in the inner surface of the arteries. And whether these cells die or whether they get damaged, and homocysteine does both, okay? When this happens, this is the beginning of the atherosclerotic process, and this is where or how the plaques that eventually we call atherosclerosis actually develop, okay? But furthermore, notice this altered state, in the present study, we demonstrate for the first time to our knowledge that homocysteine is present within advanced atheroma, and that the amount of total homocysteine is elevated in calcified biopsies. Here is what they are referring to. We have known for a very long time that in these plaques that are formed in the arteries, we find stuff like fat, cholesterol, and some minerals and some other substances. These scientists are saying that in addition to all of these, homocysteine is also accumulated in these plaques. And that's how homocysteine, again, increases the risk for potentially adverse cardiovascular complications. But there is more. Let's look at the data here. Here, notice we have total homocysteine in this axis. As it increases, in this case, aortic mineral increases as well, okay? So what homocysteine does, or elevated homocysteine more precisely does, is it stimulates the minerals to get deposited in what we call it soft body tissues. In this case, they are talking about arterial walls, but it doesn't, or it's not limited to arterial walls. Could it be brain, for example? Could it be kidneys? Could it be other body compartments, cell, tissues, organs? Now, what happens when we start depositing minerals in arteries, in arterial walls? What happens? Hardening, exactly. And hardening leads to what we discussed last night, stiffness, right? Stiffness of these arteries. So now when we have a salty meal and we drink more water, or we absorb fluids from the body compartments into the blood vessels, we cannot accommodate that extra blood or extra volume of the blood, right? And we develop elevated blood pressure, which then in itself leads to some type of cardiovascular events, especially stroke, for example, okay? Here, notice we have data that evaluated, based on 12 studies, the impact on homocysteine, or the highest homocysteine in comparison to the lowest homocysteine, on the risk of mortality from different causes. So those with the highest homocysteine level, those participants of these studies, had 66% increased risk of coronary heart disease mortality in comparison to those with the lowest homocysteine level. And they also had 68% higher risk of cardiovascular, total cardiovascular mortality. And then also all-cause mortality increased by 93%. You know what this data is also indicating? That elevated homocysteine is not just a problem for cardiovascular complications, because it seems that all the causes of mortalities were also elevated among those with the highest homocysteine level, okay? Now let's look also again about the issue for vegetarians. This is one of my publications, and notice what it says here. Vegetarians with low vitamin B12 status are predisposed to developing circulatory health problems regardless of their favorable profile of traditional heart disease risk factors. Although vegetarians do show a modest reduction in cardiovascular disease, the described research findings support the hypothesis that the compromised vitamin B12 status that leads to hyperhomocysteinemia, that means elevated homocysteine level in the blood, largely negates these benefits, okay? So there are lots of benefits of being vegetarian, but when it comes to cardiovascular disease, because of this homocysteine issue and low B12, we don't benefit as much from having lower cholesterol and lower blood pressure and so on as otherwise we would have expected. Now, another important question. Does hyperhomocysteinemia, that's again elevated homocysteine level in the blood, okay, impact other health conditions? The unfortunate answer to this question is yes. And here's one example, osteoporosis. Notice here we have data that shows that people with the highest total homocysteine concentration had 100% higher risk of having osteoporotic fracture in comparison to those with the lowest homocysteine level. By the way, I wonder, how many of you have ever heard that something called homocysteine is a risk factor for fractures? You know, when it comes to fractures, go and ask your physicians or other health professionals, or go and ask anybody on the street, and you will get likely one of two answers. The majority of the time you will hear calcium, 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 okay? The translation usually is milk, 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 or dairy products, dairy products, dairy products. The other answer that occasionally you may hear is physical activity, you know, weight-bearing activity, you know? I have yet to meet anyone who went to a physician, and the physician, whether was treating a fracture or diagnosed someone with low bone mineral density, who said, we need to check your vitamin B12 level, or we need to check your homocysteine level. It just doesn't happen. And yet, notice, it says, an increased homocysteine level appears to be a strong and independent risk factor for osteoporotic fractures in older men and women. Let's look at another one, cognitive decline and brain atrophy. Similar conditions we discussed last night in the context of another nutrient or nutrients. Moderately, notice, elevated concentrations of homocysteine or total homocysteine have been associated with an increased risk of dementia, notably Alzheimer's disease, in many cross-sectional and prospective studies. Let's look at some examples here. Notice here we have a study that look at the impact of plasma homocysteine level here, and they looked at some brain complications. Okay, 1,050 women in the study was included. This is a famous Framingham offspring study. Okay, and notice what they found in here. We found a strong independent cross-sectional association between higher plasma total homocysteine levels and lower MRI total brain volume, okay? Total brain volume. That means what? We are talking about what? Brain atrophy, right? Exactly the same condition that we talked about last night, again, in the context of different nutrient, okay? Using volumetric brain MRI in our community-based sample of middle-aged adults. This intriguing observation reaffirms data from some previous smaller studies that used semi-quantitative MRI techniques and extends their observations to younger participants. So we don't have to be 80 or something to see this type of detrimental impact, okay? Further, they say, we also found an increased risk of subclinical or covert infarcts in these participants, again in accordance with prior studies showing an association between total plasma, total homocysteine level and clinical stroke, as well as this SBI stands for silent brain infarcts. What they are talking about is that we may actually be sitting here and we may have this tiny stroke that we may not even feel it. We may see no symptom whatsoever, okay? But what if we have over a course of a day or a week, 200 of them? Or over a course of 2 years, several thousands of them. We may not feel the impact of one, but cumulatively, this may translate to, again, brain atrophy and other complications related to brain function. Yet another study, notice this study was conducted with older adults. We were over 70 to 171 of them. And in this particular study, they divided participants into two groups. In the first one, the participants received vitamin supplements that are known to decrease homocysteine level, okay? The other group received placebo, sugar pill, no intervention. The study was lasted 2 years. And here I have the results that are illustrated by two individuals, one from the treatment group, those that received these supplements, and the other from the control group. Notice this image here. This is the image of the brain. And notice it was from a female participant from the placebo group. She was 79. Baseline, that means in the beginning of the study, homocysteine was 22, and her homocysteine increased by 8 in the 2-year study period, okay? So toward the end, it was 30, okay? Notice, atrophy rate was 2.5% per year, okay? On the other hand, we have an image of a female participant from the active treatment group, the one that received these supplements, okay? She was 72 years old. Her baseline homocysteine was 24. Notice this was almost identical to the homocysteine in the other participant, but notice whose homocysteine concentration decreased by 12 over 2 years. It decreased because of what? Because the treatment protocol, right? Because she received these supplements that decrease homocysteine level, okay? Atrophy rate was 0.46% per year. Atrophy rate was 2.5, atrophy rate was 0.46. The rate of atrophy was more than 5 times slower in the participant taking B vitamins than in the subject taking placebo, okay? And in fact, when we look at these images, all the colors that we see here, light, what do you call it, turquoise type of color, right? Blue, orange, yellow, all of this is atrophy. This is where used to be brain tissue, now we have fluids. It's not nearly as visible in this particular individual. That's the impact that the homocysteine status has on brain atrophy. Here's another interesting study. This was a little smaller study, 100 participants was included in this one. They had mild cognitive impairment, and they divided these participants again into 2 groups. One, they call it low normal B12. Average or mean B12 was 235, okay? The second group was defined or called high normal B12. Serum B12 on average was 463 or so, okay? Notice what happened, or what was the difference between the outcomes in these 2 different diet groups. Mild cognitive impairment patients with low normal vitamin B12 showed a significantly poorer learning ability and recognition performance than did patients with high normal vitamin B12. Also, and this is more importantly, also the microstructure integrity of the hippocampus was lower in patients with low normal vitamin B12, okay? Now, what are they talking about? One part of the brain is called hippocampus. Hippocampus is responsible for both short and long-term memory. And today, scientists who specialize in research on Alzheimer's disease believe that the structural changes in the hippocampus area is a hallmark of being at risk of or being diagnosed later on in life with Alzheimer's disease. And these changes in the hippocampus area may already be found 25 and 30 years before the person is ever diagnosed with Alzheimer's disease, okay? So what this study is telling us is that the individuals, I'm going to go back for a second here, individuals with what was called low normal vitamin B12 already had some structural changes that were detrimental, okay? Now, by the way, do you recall still what was vitamin B12 level among the vegans, the data that I showed you? It was 172. The average B12 was 172. What it was among lacto-vegetarians, the average was 209, okay? This average here is actually higher than what was shown in the previous data set that I showed you, was found in vegetarians and non-vegans, okay? And I like to suggest to you that even though, again, this is a healthy lifestyle otherwise, that this particular issue may contribute to some complications down the road, that if we actually take a simple measure to prevent these from developing, we would otherwise not have to deal with them, okay? Now, this is what I prepared for you. Let's conclude or summarize. Aging is associated with vitamin B12 deficiency and hyperhomocysteinemia. Okay? Elevated homocysteine is associated with increased risk of, and I have depression also included here. I actually had some data on depression in this presentation for the sake of time, because I know you may want to ask me questions. I deleted some of this data, but I can tell you that the depression is absolutely one additional health condition that is related to low vitamin B12 and high homocysteine level. In fact, I know people, I sometimes go back to certain places where I lectured, and I know specific individuals who came to me and said, I used to have depression, I no longer deal with depression. This, by the way, is the same case with postpartum depression, for example. Low B12, high homocysteine is a risk factor, or are risk factors for postpartum depression as well. Okay? So here, what can be done with this information? Practical consideration. Okay? In the United States, and this is not just my opinion, okay? Anyone 50 years and over is recommended to use vitamin B12 supplements. Okay? This is because of these changes in the gastrointestinal system I outlined in the very beginning. If you were to read, for example, the Dietary Guidelines for Americans, it's a document that is issued by two departments from the US government, the Department of Health and Human Services and the Department of Agriculture. In that document, you can read the very same recommendation. Anyone over 50 years should be using vitamin B12 supplements because, again, this lower secretion of hydrochloric acid and smaller conversion of pepsinogen into pepsin and lower secretion of the intrinsic factor, okay? Another one, the dose of vitamin B12 supplement is age dependent, okay? So if you are as young as I am, you may need to have a little lower dose than if you are a bit older, okay? I have here a suggested dose, but I always recommend that we check vitamin B12 level and adjust the dose based on what you see in the serum level. So 250 to 500 should be sufficient. What I'm referring to here, if you are, say, between, say, 50 and 70, the lower dose, the 250, would likely be sufficient. When you are, say, 80 and above, for sure you will need a little higher dose, maybe 500. But again, I say this as a general recommendation because this recommendation should be verified by blood analysis. I'll give you one example. One of my good friends from the country of my origin, from Poland, sent me an email once, and the first line that I read was, what should be the dose of supplement for someone who is 88? And then the next line said, she's taking 250 micrograms of vitamin B12. And before I read any further, I was thinking, oh, that's too low for her age. But the next line said, her serum B12 is 2,000. Okay, and that's way too much. Okay, so we are all individuals. The birth date may say that we are 65, say, but biologically we may be more like 50, or we may be more like 80. You see, so these doses would have to be verified. Now, oftentimes, young moms ask me, what about children? And I believe that for children, age is an indicator of how much they should be ingested. So my recommendation usually for young children is that anyone who is up to 5 years of age, if she or he takes 5 micrograms, that should be sufficient. If anyone who is, say, between 5 and 10, if they take, say, 10 micrograms, that will be sufficient. Children seldom have absorptive issues and things of that nature, so they need much lower risk for any deficiency. Now, how would a supplement play a role in reducing risk for vitamin B12 deficiency, even though we have these changes in gastrointestinal tract that I mentioned in the beginning that prevent us from absorbing? And the reason is very simple. We actually recommend mega doses of B12 supplements. We actually call this pharmacological effect. So in the United States, the recommended intake of vitamin B12 for an adult is 2.4 micrograms. Okay? If you compare my recommendations, even the lowest dose here is about 100 times higher than what is recommended. Okay? And the other dose is about 200 times higher, or slightly more. But a small percentage of that dose will be absorbed into the bloodstream regardless of these changes in the gastrointestinal tract that I outlined in the beginning. And that's how vitamin B12 is helpful in reducing the risk of deficiency, and it's also very effective when it comes to vitamin B12 deficiency treatment. It's also utilized as, again, vitamin B12 treatment. And then notice all vegetarians, not just vegans, but all vegetarians, whether you're lacto, lacto-ovo vegetarian, should be taking vitamin B12 supplements regardless of the age. Because when we talk about individuals who are over 50, we are recommending supplements because of the changes in gastrointestinal tract. Vegetarians have a low intake or lower than adequate intake of vitamin B12, and so we have a different reason for developing vitamin B12 deficiency. And if you would like to learn a little bit more about this, I actually describe in this book some really interesting cases of vitamin B12 deficiency. Maybe I mentioned a couple. Okay? There was this one fellow who was running from door to door, from knocking on his neighbor's doors, front doors, warning them of fire. He was smelling smoke. There was no fire anywhere. This guy had B12 deficiency. You know? I described another fellow who was convinced, absolutely convinced that the IRS is after him, and the IRS agents are trying to shoot him through the microwave. That was his conviction. He had vitamin B12 deficiency. And I have, again, cases from infants through all the adults, described many different ones, and I think it's actually quite fascinating reading. So if you would be interested, the source is available. I don't have this with me for sale, but you can order this through me. So I actually have here in my hand vitamin B12 supplements. I buy these in Walmart, okay? This is a 200-count bottle with 500 micrograms of vitamin B12. I paid for this $4.14. And this, I believe, is about 1 year worth of B12 supplements. For about $4, we can prevent the conditions that we were discussing here, okay? So my philosophy, as I mentioned to you last night, is if you need to take a supplement, as long as it's the right dose, choose the cheapest one. There is no need to buy something that costs more. I know people who sell supplements good for 1 month for over $40. I'd like to suggest to you that they make good money on this. I don't have any connection with any pharmaceutical organization or any other manufacturing plant of supplements. I don't get any profit from any sale of any supplements. I just simply share with you what I studied. Vitamin B12 is my main area of research. And I also share with you something that I myself practice because I've been using these supplements for many years. With that, I'm going to ask you if you have any questions. And okay, we have a mic. So if you have a question, let's use the mic so we all can hear you. And if I know the answer, I'll be happy to answer your question. Okay?
Wait a second. So we got the mic because it's live stream, so the people who are watching they can hear the question.
And an alternative would be I can repeat the question or summarize the question, and they probably will hear me, right? Yeah? Okay. I think, sir, you were first, I think.
Yes.
Could you say this one more time, sir? If vitamin B12 supplements or something new? Oh, no. Oh, So vitamin B12, the studies on vitamin B12 date back many, many, many decades. Now, vitamin B12 is one area, vitamin B12 research is one area to invest in, according to the National Institutes of Health, for example. So when you look at the volume of studies that are being published on vitamin B12, I'll give you one example. When I was writing this book, I forget now, was it 2016, 17, I forget. I actually, in September, I did a PubMed search. PubMed is a medical database. This was in September, from January to September, over 1,100 papers, scientific papers, were published on vitamin B12. Even if you specialize in it, which is what I do, it's impossible to read all of them. You see, it's impossible to read all of them. So it's not anything new. We can go back to 1950s, and even 1948 was when vitamin B12 was discovered. Okay, but even earlier, there was a publication or a research done when in 1920s, when scientists didn't even know of vitamin B12. But what they knew was that an extract from the liver was, effective in treating pernicious anemia. Okay, they didn't know what it was in the liver, but the extract was, and then in 1948, they discovered for the first time vitamin B12, and from 1950s on, we have many, many publications on vitamin B12. Yes, ma'am.
Yeah, I have a question about the measurement of the vitamin B12 and the homocysteine. So you said you could get a blood test to check your
Yes.
B12 level. Is there also a reliable test for your homocysteine level?
Yes, okay, good question. So it's actually a little complicated, I have to admit. So vitamin B12 can be measured directly, like in serum, okay? And it can be measured indirectly. And some of the indirect measurements of vitamin B12 are actually more reliable than the direct measurements. So for example, things like something called, and I have to use those terms since I was asked the question, things like methylmalonic acid, okay? It's a metabolite on vitamin B12. And when it is elevated, it indicates an early stage of inadequate vitamin B12 status, okay? Another one is called holotranscobalamin 2. And please don't blame me for all these terms. I didn't come up with them, okay? But it's another very reliable way of measuring vitamin B12. The one thing that all scientists who do research on vitamin B12 agree on is that you cannot rely just on one test of vitamin B12. You need to use at least two. Because, for example, another test to assess vitamin B12 level is one we call MCV. That stands for mean corpuscular volume. That's a measure of the size of red blood cells. Because we know that if you have vitamin B12 deficiency, the red blood cells will actually be larger than normal. Okay? So elevated MCV is likely the reason or indicative of low B12. But imagine a scenario where you are deficient in iron, and in the same time you are deficient in vitamin B12. You know what iron does? Iron causes red blood cells to become smaller. B12 deficiency causes red blood cells to become bigger. So if you have an individual, if you have a patient that has both nutrient deficiencies, you may have a perfect level of MCV, and you may say, okay, it's not B12, whereas you just missed two nutrient deficiencies, you see? So, again, the recommendation usually is check your homocysteine level, check your serum B12, for example, or if you have the opportunity to check, say, this methylmalonic acid. I will, at the end of the next question, I will have my email on the screen. Any one of you who, a question will pop into your head sometimes down the road, you can email, and I will be happy also to write and spell out these measurements and stuff like that. But yes, both homocysteine and B12 can be measured. Homocysteine can be measured in the serum. Homocysteine can also be measured in the urine. The serum one is a better marker than the urine, but yeah, they both can be measured. Follow up?
Part two of that question. Are they stable from day to day, week to week, hour to hour?
Well, Yes and no. So when, if you ingest something that contains vitamin B12, say, and you are deficient and you don't have too much of the absorptive issues, right? In any nutrient deficiency, when you actually ingest that nutrient, the body will go in overdrive to absorb it because it perceives that it needs more of it, right? So if you just measure this right after you ingested that, it will be not reflective what it was prior to that, you see? But it's not, other than that, we don't have, too many swings, right? Another thing is, things like homocysteine is not just impacted by, say, vitamin B12. For example, you have someone who has kidney problems, kidney insufficiencies, okay? It may be elevated homocysteine, may be related to that, you see? So there are some other individuals. Oftentimes I tell, and I love to do that, I don't mind doing that, I love to do that. I give my email to all participants who come to my programs for a reason. If they need, say, interpretation of their laboratory findings, I'm glad to do that, So you'll have this opportunity after the end. Yes, sir.
Thank you. First, I would like to ask, see, I'm a little bit confused. There are some people are saying there are a lot of fake supplements on the market. And I was stunned to hear that you buy the lowest price because I pay over $30 for mine. So the question is, how do you filter this? How do you navigate through all of those? Because there is abundance of supplements. How do you choose the right one? Is there a secret?
Excellent question. And I shared last night with you that we have roughly about 75,000 of different supplements out there, right? And, the manufacturers would like all of us to take all of them, I have not studied all supplements, okay? I studied some more than those that I talk about and more than those that I recommend. Some are absolutely bogus, but I do believe that some are important. DHA, especially EPA, DHA was one I shared with you last night. B12, and considering that you live just south of Chicago, we are entering the time when all of you will likely need vitamin D supplements as well, okay? And they're effective in increasing vitamin D level and not dealing with vitamin D insufficiency or deficiency and complications related to that. I think there might be another supplement that some people in the general public might benefit from. I'm referring to the microbiome, okay? The microbiota, the probiotics, okay? Probiotics. We know, for example, that patients who have some type of skin conditions, some other complications, eczema, things of that nature, even asthma, even they have been shown to be effective in reducing risk for Parkinson's and Alzheimer's, okay? Now, I say this with a little caution because I have not studied this particular aspect not as much as some of the other nutrients or other issues, but I am actually in the middle of writing what I refer to as a concept paper for one of my studies, in which we will be studying actually milk content of microbes in the mother from vegans and not vegetarians and non-vegetarian participants, and then how the profile of the microbes in that milk colonizes in the infant's intestines, okay? And so that's why I started reading about this, and I see that there might be some support for some individuals to use those, There are many other supplements and where there are some studies that support maybe the use of some of them, oftentimes paid for by the industry, okay? So I don't believe that many of us should be taking many more supplements, though there might be stages of life. For example, if you are pregnant, say, you are recommended to use multivitamin or prenatal vitamin, right? There might be stages of life where some additional supplements may be needed. Just this week, in one of my classes, I teach a class called life cycle nutrition. Life cycle means from birth, or really prior to that, when you are pregnant, until you are centenarian, right, over 100 years old. And I shared with my students data on preventing preeclampsia, okay, hypertensive type of issues in pregnancy. We know that higher intake than even recommended of calcium, even in a form of calcium supplements, prevents from developing eclampsia. But again, this is not a universally recommended supplement. In fact, I can share with you maybe one day down the road, if I come back to you, that supplements of calcium for prevention of osteoporosis are completely ineffective, for example. So I personally do not recommend calcium supplements for anyone older, adult and elderly, because they are completely ineffective in preventing this. But there may be other groups, like, again, pregnant women, that may benefit from this, okay? So, that's as much as I can tell. Again, there's too many of them to address each one of them, and a lot of them it's simply bogus. Yes. Yes, sir.
Okay, so my... Am I okay now? Oh, that's much better. Man's original diet, vegetarian, plant-based.
Yes.
Man was originally much healthier than he is now. But back in that time, there were no B12 supplements.
Yes.
So what do you just propose might have been coming into play at the time?
Excellent question. No, actually, in the book of Genesis, chapter 10, verse 1, it says that Adam and Eve went to the supplement store and bought vitamin B12 regularly. I shared with you this morning that I am a fellow Christian. I'm actually a Seventh-day Adventist, and I definitely accept the biblical story of creation and Genesis and all that. I don't know if I have a very good answer to that, but I want you to think about something, okay? Did people in the Garden of Eden, Adam and Eve, did they have to have a bowel movement? What do you think? I don't know the answer to that question. Remember last night I actually mentioned to you that in the large intestines, the bacteria in the large intestines produces massive amount of B12. Could it be? I don't know the answer to it, but isn't it possible that maybe back in those days, they actually made a use of it? We are not absorbing that B12. We can absorb vitamin K, also produced by the same bacteria from the colon. We don't absorb vitamin B12, That's one thing to think about. Another one is, we know from the fossil record that prior to the flood, we had some animals living on this earth that we no longer have with us. The examples would be dinosaurs, right? Okay? Isn't it possible, again, I don't know the answer to this question, but isn't it possible that prior to the flood, there may have been plants, fruits, things those people ate that are no longer with us today, that may have contained vitamin B12, Again, I don't know. I was thinking about that because, how is it? The reality is we are no longer in the Garden of Eden. Did you notice? And they didn't have a need for any supplement, really. If you go ever to, say, an Asian store, okay, or a Walmart Supercenter, whatever store, look at the abundance of fruits and veggies, right? We don't even have Caesars any longer. But this is like nothing in comparison to what they had in the Garden of Eden, right? Everything was available in a perfect ripeness with a perfect nutrient content, right? We are not in the same environment. We are living way past that time. The Bible says the sin entered. And for anyone who doesn't believe in that story, I don't know where those people have been. Look around. The sin is everywhere, right? And we reap the result of the sin. So I don't know how it was. Jesus will answer this one day, okay? But I think that there is a sensible explanation that the conditions back then were a little bit different, and they just might have had things that we don't have available today. So.
Hi, I have a three-part question.
You have to give me one at a time because
Okay.
at my age you tend to forget, stuff, so.
The source of your vitamin B, do you know where it's sourced from, or what?
I do.
Is it plant-based?
Okay, very good question. So there's more than one aspect to this question. Sometimes you go to a store and you actually read on the label, vegan vitamin B12 or something, It's either vegan and that means it does not contain B12, or it is B12 but it is not vegan. You know why I say that? Because there is no such thing as vegan vitamin B12. All B12 is derived from bacteria. It's a byproduct of feeding or keeping large amounts of bacteria in big bins where they are being fed with beet broth, okay? And they isolate B12 as a byproduct of keeping that bacteria. So whether we are talking bacteria in meat, for example, vitamin B12 rather in meat, it comes because the animals have massive amount of bacteria in the gastrointestinal system, and that bacteria, that B12 is then spread throughout, the animal and goes into the muscles and so on. The same in milk and stuff like that. And the same is when it comes to supplements. It all comes from bacteria. How exactly they isolate that, I don't know. I actually called more than once manufacturers and asked them. I said, look, this is my area. I publish on this. I do research. I would like to know how you do that. And they are afraid that I want to, establish a competing company, whatever, and they don't give you that information. But all comes from bacteria. Only microorganisms, such as bacteria, are able to synthesize vitamin B12. And that's where B12 comes from.
Okay, so the supplement that you showed is not a vegan or vegetarian.
Well, again, all supplements. There is no supplement with B12 that is vegan, okay?
Well,
this B12 in here is isolated from bacteria. Yes.
Okay, I take one that's isolated from a Chardonnay, the meat of the inside of the Chardonnay seed, and it's vegetarian.
No, it's impossible.
Okay, my next question is, do you know about the efficacy of and the bioavailability of the supplement you take?
Absolutely. It's actually supplements, as long as we apply the dose that we know are effective, have the same efficacy as B12 injections. Yes. Whether we are talking treatments or maintenance of vitamin B12. In fact, there are some, let me elaborate a little bit, there are some benefits of using this versus an injection. Because an injection, I'm talking about maintenance. Individuals who have low B12, they are injected with B12 once a month, okay, for maintenance so they don't develop deficiency. But the little issue with that is that shortly after the injection, they feel absolutely great. But then this effect falls off, like wears off, and shortly before the next injection, they feel progressively worse. When you take B12 supplements on a regular basis, you don't have these mood swings, But the efficacy, whether, again, we are talking treatment or maintenance, is the same.
Okay, and my last question is, it's my understanding that a B complex with all the 8 B vitamins helps the B12 to work better because they all work off of each other, kind of like the spokes on a wheel. So,
I disagree with that. I don't see really much of any interaction in terms of absorption, for example. There is one B vitamin, it's called folate or folic acid, that I oftentimes, when I teach students, I tell them it's a cousin of vitamin B12. When you look at the metabolism, folate and B12 actually activate each other, so there's one vitamin. But I actually personally don't recommend a B complex. And the reason why I don't is because I believe that some of those vitamins in B complex we absolutely don't need. I really can't perceive anyone who lives in the United States who may need, say, thiamine, which is vitamin B1, for example. If you live in Malawi or Somalia, you may have multiple nutrient deficiencies and you may benefit from it. But in the United States, I don't believe that's the case. Just to give you an example, when we eat flour or grain products, the flour is of nutrients such as B1, B2, B3, folic acid, and iron are added to the flour. Okay, so we get B12, B1, for example, from that source. Another reason why I don't recommend B complex is because usually the dose of B12 is too low in B complex. The highest that I've seen the highest dose of B12 in the complex was 50 micrograms, in comparison to what I recommended here, which was 250, for example, although lower doses might be okay for people who are a bit younger, but 50 is, in my opinion, too small a dose. And yet the third reason why I don't recommend B complex is because it also contains folic acid. And folic acid, I believe we should obtain from foods. We actually can do that, especially when we eat beans. Beans are the highest, soybeans is the highest source. And folic acid supplements have been linked to increased risk of some cancers. So while folic acid or folate is an important vitamin, we should focus on foods rather than taking them from supplements. But again, in the B complex, we would find also folic acid.
Okay, next. I see the hand.
Okay, let me ask, before we go on, my mom, sir, are we going to delay the second one? Or?
No, we are starting at 3:30. We have
So,
7 minutes for
so
questions
if,
and 5 minutes for break.
would you mind, let me take one more question, and if you have more, okay, I will have yet another lecture, and then we can deal with questions until about 9:30 in the morning, because our flight leaves at 9:30 in the morning, so we'll have way more time, you know. Yes, sir.
Thank you. I'm a long-time vegan. I take B12 supplements, and my CBC results consistently show what my doctor declares as too much B12. She's always asking me to cut back, and I tell her that there's no such thing as an excess of B12, and it's water soluble, and I will overdose. Am I on solid ground with that?
A very good question. Now, in order for me to actually address whether your level is too high or not, I would have to know exactly how much it is. But B12 is considered non-toxic vitamin, even though there are some cases, there are some individuals that do develop toxicity symptoms. Most of the symptoms have to do with skin inflammation, acne-like type of conditions where you scratch, you feel itchy and redness type of thing, These are most of the time the toxic symptoms of vitamin B12. But only a small percentage of individuals with very high serum B12 develop these conditions. So again, whether your biochemical level shows too high, I would have to know exactly how much it is, okay? But generally speaking, not many people develop toxicity symptoms, although there are some people who do. For example, one of my colleagues actually wrote a paper with her, and she started taking B12 supplements, and her level was over 1,200. And she told me that she is already feeling, the scratchy type of inflammatory type of, patches on her skin. By the way, if you want to go and check your vitamin B12 level, serum vitamin B12 level, I always recommend that B12 should be somewhere between 750 to 500, okay? Forget the units, 750 to 500. Do not rely on, physician or someone in physician's office calling you, telling you your B12 is normal. You know why? Because oftentimes the cutoff for, quote, normal B12 is 180, okay? 180. Remember, we look at the data, you need about 330 to keep homocysteine at the level that is considered safe, right? It should be considerably higher, okay? So if you want to check your B12, ask, you paid for it, this is your value, your lab result. You can look at this and interpret it for yourself, or you can email me, I'll help you to reinterpret this. But if it's 500 to 750, it should be adequate. Okay, the very last quick answer. And
yes.
Last
question for me. I know I have only two, so thank you. I seen my doctor last time when I saw him. I asked for a vitamin D3 test, and he said no. And I asked why, and he said it's controversial. Can you say anything about that? Do I have to fire my doctor?
Let me tell you this. there are many studies that show the benefits of maintaining adequate vitamin D level, okay? There are some studies that may not have shown an effect, okay? The results depend often on possibly multiple factors, okay? But if you look at, for example, a recommendation of the Endocrine Society, they definitely consider anything less than 30 serum by B12 level insufficient. And what we know that it is insufficient. You know why? Because we have elevated parathyroid hormone. Parathyroid hormone, when it is elevated, it means that the parathyroid hormone is trying to stimulate the kidneys to activate vitamin D, to activate rather conversion of vitamin D into the active vitamin D compound, you see? So we know, even if we dismiss all the different health effects, whether cardiovascular benefits or some benefits for reducing cancer risk, when we look at, again, the parathyroid hormone level, which again is elevated when we need more vitamin D, that would be indicative of whether we have to increase the level or not. So I would disagree that it's a controversial. There's a lot of, quite a mountain of evidence that show the benefits from slightly higher, or let's call it normal vitamin D level. So, okay,
Thank you.
we have 5 minutes, and I actually have to go upstairs and look at the presentations because we are using Mac computer. My presentations are created on PC, so there's some distortion. We need to look and correct some formatting